Okay, 11.5 for topic 11 part 1 deals with just two-way frequency tables. And this is just a method or a way to organize data and use it to make inferences or predictions about a group. So the only example we're going to have today is creating and then using a two-way table to determine probabilities of events occurring. So example 1. They ask you to create a two-way table. You look at it, they tell us that we have a total of 120 people. They respond to a survey about a mascot. Number of teenagers that chose mascot A is 37. Number of teenagers that chose mascot B is 41. Number of adults that chose mascot B is 21. So they give you tons of information in here. We need to build the puzzle. Okay, we need to start throwing in these numbers into the cells they belong. So first off, total of 120 people. That total is going to go all the way down here in the bottom right. So if you look up top, okay, totals are in my right column, and they're also in the bottom row. So the total amount of people is going to go all the way down here in the bottom right. Moving along, it says the number of teenagers that chose mascot A is 37. So I'm going to go to teenagers. Mascot A is going to be this top left cell, so that's 37. Number of teenagers that chose mascot B, so teenagers, mascot B, right here, 41. Now, we know that the total amount of teenagers is going to be these two cells added together. So 37, 41 gives me 78 total teenagers in this survey that they ran. Last one they give us is the number of adults that chose mascot B. So I have adults, mascot B, 21. Since I have 21 adults for mascot B, we can go ahead and find the total that chose mascot B to be 62. It's just adding the two of them together. From here, they didn't give us the other values, but we can use our skills to figure out what these other cells should be. So I'm going to go ahead and figure out what this top right cell is first. I know that these two added together, so the blank plus 62 has to get me to 120. So if you want, you could write an equation, or we could just use common sense and think logically through this. What plus 62 gets me to 120 happens to be 58. Okay, 58, 62, they get me to 120. I'm now going to look at this cell right here. If I know the total of people that picked mascot A is 58, we know 37 plus a number has to get me to 58. That number just so happens to be 21. And then my last cell, there's two ways you can do it. We can think 78 plus what gets me to 120, or probably the easy way is just I have the adults for mascot A, adults for mascot B, add them up, gets us to 42. Okay? So that's taking the results of a survey and just organizing them into two-way tables. So I can look at these cells to help figure out like what people prefer. We now want to use that table to find a probability for each of these 6 questions below. For a probability, it's either going to be from 0 to 1. Okay, so it's the number from 0 to 1. It could be a fraction, or you could have a percentage. Typically, though, we like to keep it as a number from 0 to 1. On these, you just look at the question. So number 1, they want to know what is the probability that a randomly selected person is a teenager choosing mascot B. So first off, we are looking at just a randomly selected person. So we are pulling from the whole group. We're going to make a fraction. Our denominator is the total people we are choosing from. So we're choosing from any person in this group. And we want a teenager that chose mascot B. So we go to teenagers, mascot B. There's 41 of them. Okay, so we have 41 out of 120 people chose mascot B. Truly, you can leave it like a fraction, or if we go into the calculator, we can get a decimal. Either one of these would work for me. So it's either 41 1/20ths, or we could say it's 0.34. 2, they want to know what is the probability that a randomly selected person, so again, randomly selected person, we're going from the whole group, denominator is 120, chooses mascot A. Okay, so they don't have any stipulation on who this person needs to be. They don't talk about being an adult, a teenager, anything like that. They just want a person that chose mascot A. So the total amount of people that chose mascot A was 58. 58 is going to go up top. And then again, if you want it as a fraction, leave it. If you want decimal, divide it out in the calculator. Gives me a 0.48. 3. What is the probability that a randomly selected person is an adult? So again, randomly selected person. So I'm going out of 120. Probability it's an adult. How many adults do we have? We had 42. There's my fraction. You can go ahead and divide 42 over 120. Gives me 0.35 as my decimal. Okay, these last three get a little interesting because our total amount of people we're dealing with changes here. For 4, you want to know what's the probability that a randomly selected teenager. Okay, so now we are picking from the teenagers. You look at our 2A table. How many teenagers do we have altogether? 78. That's now your denominator. Okay, because we are choosing from just the teenagers. So probability a randomly selected teenager chose mascot A. Mascot A, 37 of them, of the teenagers chose mascot A. So we're left with 37 over 28. 37 over 78. Go ahead, divide that out. Gives me a decimal 0.47. 5, they want a randomly selected person choosing mascot B. Okay, so I have a randomly selected person who chose mascot B. So we have to look at how many people chose mascot B. There were 62 of them. And they want to know what's the probability that they are an adult. So that leaves us with 21 over 62. Gives me 0.338. I'm going to round it up to 0.34. And then the last question with this 2A table is what's the probability that a randomly selected adult. Okay, so this is different. You're now looking with just the adults. Okay, so I have total amount of adults is 42. And they want to know what's the probability that the adult chose mascot B. So how many adults chose mascot B? 21. The 21 over 42. And that's how we got the 0.5. So that's section 11.5 and then topic 11 notes, part 1.